Okay, so 2.2 again is all about the slope. And the slope is just a ratio. Ratio means it's a fraction. And the slope is a ratio of the rise over the run. And the rise is the up and down part, so that's the y part. And the run is the left and the right part, so that's your x. So when we talk about the slope, that slope is going to be the rise, which is the y component, over the run, which is the x component. Now there are 4 basic types of slope. 2 diagonal lines, and then a vertical and a horizontal line. So let's look at a line that goes down from left to right. If I give you this line and it goes down from left to right, what does that tell me about the slope? Well, if it goes down from left to right, then my slope is going to be a negative value. So if it goes down from left to right, it's negative. And the opposite is when it goes up. So when it goes up from left to right, that's called an increasing function. You'll probably hear that in college algebra. In college algebra, they'll use terms like increasing function. And this would be going up from left to right. And what does that mean my slope's going to be? It means my slope is going to be positive, right? Because you went up from left to right. You go down, it's negative, decreasing function. When it goes up, increasing function and a positive slope. Now, what about the vertical and the horizontal lines? Let's first talk about the vertical line. Let's try to remember what this slope is going to be. It's either going to be 0 or it's going to be undefined. So we're going to first look at a vertical line. Does anyone remember if this is going to be an undefined slope or a 0 slope? Does anyone remember? Yep, it's going to be undefined. Very good. So this one's going to be undefined. And that's a vertical line. Okay. And why is it undefined? Well, we go back and we think about our definition of a slope. It's rise over run. And you're not going left or right any. You're only going up and down. And when you take a number and divide it by 0, that can't happen. That's called undefined. So just remember that vertical lines are undefined when it comes to the slope. What about a horizontal line? That one's going to be the opposite. And what would the slope of a horizontal line then be? That slope would be m equals what? Does anyone remember?
0.
Yep, 0. So a horizontal line has a slope of 0. Now I'm going to give you a line, and you're going to find the slope of this line. So I'm going to give you a slope here, or a line here, and we're going to find the slope. And first thing I like to do is I like to think about whether the slope is positive, negative, 0, or undefined. So is this going to be a positive slope or a negative slope? Which one? If we look at it, what's it doing from left to right? Going down, right? Think of it like a stock market. When you look at the chart of the stock market, okay, this is going down from left to right, so that means my slope is going to be negative. What does the slope mean? The slope is rise over run. And so that again is y over the x. Now what we're going to do is we're going to go from one point to the other point. So we're going to go from one point here, and I'll try to use a different color. So we're going to go from this marker that works here. We're going to go from this point right here to this point right here. Okay? Now, we can only go up, down, left, right. So what do we have to do to go from this point to this point? Well, to go from this point to this point, we're going to have to go down 6, right? This is up 6 units. You're going to have to go down 6, and then you're going to have to go over 2. So this is your x part. This is your y part. So what would my slope then be? Yep. Slope isn't going to be y over x, which is going to be negative 6 over 2. And you always reduce it, and so that's going to come out to then be what? Negative 3. And that makes sense with what we found earlier, because that slope should be negative, and our slope is negative, right? Always double check things by first figuring out, is it positive or if it's negative. That way, if you make a mistake when you work out the algebra, you'll find it. So when I look at this line, it's going down from left to right. So that means my slope is negative. We can also find the slope when we have 2 points. And there is a formula that we can use to find the slope given 2 points. And when we want to find the slope, m represents the slope. So lowercase m is going to represent the slope. And our formula is m equals y1 minus y2 over x1 minus x2. Now the textbook has y2 minus y1 over x2 minus x1. It's the same formula. I think it's easier to go from 1 to 2 than 2 to 1. I think you're less likely to make a mistake this way, so this is the way I read it. 1 and 2, we go up instead of down. You're less likely to make a mistake when you use this formula. Textbook has it as y2 minus y1 over x2 minus x1. It's the same as this. Okay? I always like to write 1 first, then 2. The textbook does it the other way because that's the way it was derived, but I think this is actually easier to use. So here's our formula. And we use this formula when we want to find the slope when we're given 2 points. So let's go ahead now and find the slope when you're given these 2 points. And let's say you're given, and this can work with fractions, this can work with decimals, or it can work with whole numbers. So let's say you're given minus 5/8 and 3 negative 2. And I want you to find the slope. Now, all the formulas are going to be pretty much done the same. You take your ordered pairs and you label them x1 and y1. So let's go ahead and do that. We take our first point, and that's going to be x1, y1. Our second point, we'll call that x2, y2. Now, where students make a mistake, if they make a mistake, is it's either they accidentally put the x's on the top, or they're not careful with the double negatives, because sometimes you will have double negatives. Again, I always like to write the formula out. Every time I use it, it just reinforces that formula. So m equals y1 minus y2 over x1 minus x2. And I'm going to go ahead now and fill in my ordered pairs. Remember, y goes on the top, x goes down below. So y1, which is 8, and watch your signs here, minus y2, which is a minus 2. So notice there's going to be a double negative. Down below, we have x1, which is a minus 5, minus 3 for x2. We're going to go ahead and work this one out. So we know the double negative here makes that then positive. So the numerator is going to come out to be a positive 10. The denominator, minus 5 minus 3 makes it a minus 8. We can rewrite this. We can reduce it a bit, and the negative can come up to the top. The 10 and 8 both have a 2 in common. So I'm going to reduce that down to a minus 5/4. So everyone notice how I did that? Pretty easy, as long as you're careful with the formulas. Let's do one more, and then we'll talk about how to find the slope from an equation and how to graph that equation as well. So let's do one more of these, and we're going to try and find the slope. And let's see, you're given two ordered pairs. How about 5, -4, and 3, -4. Now, when you look at this, what do you notice at the very beginning? Well, you should notice that the y's are going to be the what? The same, okay? And that's going to change our slope a bit. It's not going to be a whole number. It's either going to be 0 or it's going to be undefined because these are the same. So let's work it out, and let's see what we've got. We've got x1, y1, x2, y2. Write up our formula. M equals y1 minus y2 over x1 minus x2. Fill it in. Minus 4 minus a minus 4 over 5 minus 3. Always be very careful and take your time with the double negatives. The double negatives here make this then positive, and minus 4 plus 4 makes it 0. 5 minus 3 is a 2. 0 divided by any number is what? 0. So your answer on that one then would be 0. So pretty simple to find the slope. How do we graph a line when we're given a point and a slope? Well, let's do that next. So I want you to graph this line, and you're given a point and a slope. Now, when we graph lines, there's 3 different ways that we can graph them. Okay? We can graph a line when we have 2 points. We just did that back in 2-1. If you have 2 points, you just take a ruler or a straight edge and you connect them together. Right? Plot your points, connect them together. You can graph a line when you have a point and a provided slope. You can also graph a line, which we'll do here in a few minutes, when you have just an equation. So we're going to go ahead and graph this one when you're given a point and you're given a slope. Now, what you want to first do is you want to find your point. So we're going to plot our point on our graph. And we are starting at 8, 2. So 8, negative 2. That means we go over 8 units and down 2 units. Okay, and that's 8, negative 2. Now, what is our slope? Our slope is a negative 2/3. So since our slope is a negative 2/3, that means we go down 2 units and we're going to go over 3 units. Down 2, over 3. You always go to the right, never to the left. If it's positive, you go up. If it's negative, you go down. So we start at our point, 8, negative 2. We're going to have to go down 2 units and over 3 units. And that's going to make my second point. And if you want to, you can go ahead and label that ordered pair. Okay, so we're going to have to go over 3, so that makes it 8, plus 3 makes it 11. And down 2, so minus 2, down another 2 makes it a minus 4. You don't have to label the ordered pairs, but if you want to, you can. So we went down 2, over 3, and we labeled our ordered pair. Now, when we go to graph these, it should be going down. Why should it go down? Because my slope is negative. So that way, we know if we did it correctly just by looking at it. Well, looks like we did it correctly because our line is going down. Our slope is negative. Let's try one more of these, and then we'll look at an undefined slope, and then we'll look at equations. We're going to go ahead and now graph the line. You're going to be given a point and a slope. So easy enough. Plot our point. Be careful when you plot these. Remember, that's x and y. So 1, negative 5. That's one of the most commonly mistakes I see. The students, sometimes when you plot them, you might get in a hurry and get the x and the y mixed up. So take your time. 1, negative 5. That means my x part is 1. So we go forward 1 unit, and we go down 5. So we're going to start right here at 1, comma, negative 5. Now, what is my slope? M is 2. I'm going to write that as a 2 over 1. It's positive, so that means we go up 2, and then we go over 1. So up 2 and forward 1 unit. So up 1, 2, and over 1 unit. And if it helps, you can always label your ordered pair. Okay, your ordered pair, we went up 2, over 1. So we're at 1, we went over 1, so that makes it a 2. And negative 5, we went up 2, that makes it a negative 3. There's my 2 points. We connect them together. And that's going to make our line. And again, we know that we did it correctly because our line should be going up from left to right. And when we look at it, it is going up from left to right. One more, and let's talk about an undefined slope. Now, when it's an undefined slope, we can't make a fraction to move. So what we look at is we think about it's undefined. So what does it mean if it's an undefined slope? So let's go back and look at what we just talked about a few minutes ago. So a few minutes ago, remember when we looked at these, when we had an undefined slope, it was a vertical line, right? So undefined slope means it's going to be a vertical line. So how do we graph this? Well, we first need to plot our point. So our point is 3, -5. So that's going to be over 3 and then down 5. So right here is 3, -5. Now, it's undefined, and undefined slopes are vertical lines. So this undefined slope is going to be a vertical line. So all we need to then do is just draw our vertical line here. And that's it. That's your line right there. It's a vertical line. And we plotted our point. We just draw our vertical line straight through it. The last part of this section is how to find the slope and how to graph a line when you're given an equation. Instead of making a table or a chart or filling in ordered pairs, we can use the equation itself to graph the line. And we're going to be looking at what's called slope-intercept form. And you're probably, many of you, familiar with this already. And your slope-intercept form is y equals mx plus b. And that m, well, that represents the slope. And the b, that represents your y-intercept as an ordered pair 0, b. So there's two ways we can write a line. We can either use slope-intercept form, or we can use what's called standard form. And standard form we'll talk about after break. That's in 2-3. So in this section, we're talking about slope-intercept. So the number in front of the x, well, that is your slope. The number on the end is your y-intercept, the starting point. We're now going to graph some of these equations by finding the slope and the y-intercept. So we're going to find the slope, y-intercept, and graph. I picked one that was already in slope-intercept form. When we go to graph these, we need to make sure, first off, that it's been solved for y. Has it been solved for y already? Yes. If it's not, which we'll look at some of these in a moment, if it's not been solved for y, then we do that. This one we didn't have to. It's already been solved for y. Now what we look at is we look at the number in front of the x. And what's our number in front of the x here? So that means my slope is going to be a -2/5. And this 4, well, that represents the y-intercept. And we always want to write that as an ordered pair. So that's going to be 0, 4. And now we have everything that we need to graph this line, because we've got a point, right? And we've got a slope. So we can graph the line from that point and that y-intercept. Remember, the y-intercept is just a point. So where do we start at? We started our y-intercept, which is at 0, 4. So at 0, and then up 1, 2, 3, 4. Crosses the y-axis right there. Now, what are we going to do? We take that point that we have, that 0, 4, and then we move according to our slope. Our slope is negative, so we're going to be going down. So we're going to have to go down 2 over 5. So we start at that 0, 4, and we're going to go down 2, and then we're going to go over 5. Okay, so down 2 and over 5. And if you want to, you can label the ordered pairs. So down 2 over 5, so that's going to be at 5, 2. Down 2 over 5. Now we can connect them together, and we've got our line. You don't have to label that point 5, 2. If you don't want to label it, you don't have to. You can just count units and go over. So what did I do to get to that point? I went down 2, right? And then I went over 5 units. So down 2 and over 5. The next one is not going to be solved for y. So we're going to have to solve it for y. Same procedure. Find the slope, y-intercept, and we want to graph this. So this is what we've got. Now, right now it's in what's called standard form. And when we go to graph these equations, we cannot graph it from standard form. So what we need to do is we need to get it in slope-intercept form. And so that means our first step is going to be we're going to solve it for y. So step number 1 is going to be solve for y. And that means we move that 4x over. And then we've got minus 2y equals minus 4x minus 10. How do we finish it? Well, we have to divide everything by a minus 2 because we're solving this literal equation here. Solving it for y. So we divide everything by a minus 2. And now we've got y equals, you reduce your fractions if possible. Minus 4 divided by minus 2. Negative and negative makes it positive. 4 divided by 2 leaves you with the 2. Minus 10 over minus 2. Negative over negative again makes it positive 5. Has it been solved for y? Yes, it has. So that means that this 2 in front, what does that represent? This 2 right here, well, that represents your slope. So your slope is 2. And the 5, that represents your y-intercept. As an ordered pair, that would then be 0, 5. It's always 0, whatever number is there. On the last one, it was a 4, so it was 0, 4. This one has a 5 on the end. That's your y-intercept, and so it's 0, 5. Now we should be able to quickly graph this line here. Our slope is positive, so we're going to be going up from left to right. We start at 0, 5. And what is my slope? My slope is 2 over 1. So that means we go up 2 units to go over 1. up 2 over 1. Make our new dot. If you want to, you can label it. If we label it, it's going to be at 1 and went up 2 units, so it's going to be at 1, 7. Again, you don't have to label these if you don't want to, but we went over 1 unit here and went up 2. Now we've got our 2 ordered pairs, and we can connect them together. I want to do 3 more of these before we talk about parallel and perpendicular lines, because I want you to see the 3 cases that can also happen. So far I've only looked at diagonal lines. We've looked at a positive one, we've looked at a negative one. Now there's also vertical and horizontal lines. And we can also have something that goes through 0, 0. So let's try to graph this line here. How about 5x plus y equals 0? Now this one's easy to do, but sometimes students may get confused as to where do I start. So first things first, I have an equation, and anytime you've got an equation in this chapter, if you don't know what to do, chances are you're going to want to solve it for y. So we're going to go ahead and graph this line. We're also going to find the slope and the y-intercept. So we're going to graph this line. We're going to find the slope and the y-intercept. So if it has not been solved for y, that is what we do. So if in doubt and you have an equation and you don't know what to do, chances are if you solve for y, that'll get you going in the right direction. So we're going to move that 5x over. And now we've got y equals a minus 5x. So the number in front of the x, in this case, is a negative 5. And so that means my slope is a negative 5. And there's no number on the end. If there's no number on the end, then it's like having a 0 there. So this is like having a plus 0. And that means that this piece right here, it's 0 there, that means that my y-intercept would be 0, 0. So if there's no number on the end, that means your y-intercept there is going to be 0, 0. So always remember, solve it for y. If there's no number, that means there's actually a 0 there. So that means your y-intercept is the origin, and that's at 0, 0. How do we graph it? Well, we quickly graph it. Start at 0, 0. What's my slope? Yep, negative 5. And we're going to write that as negative 5 over 1. So we're going to have to go down 5 units and forward 1 unit. So down 5 over 1 unit. Make our new dot. And that would be at now 1 comma negative 5 as an ordered pair. Again, you don't have to label it. I always like to. That way, when you're going back and looking at your notes, you can see how I got that extra point. So we've got that. We can graph it now just by connecting these together. And there is our line. So we have our y-intercept at 0, 0. And we have a slope at negative 5. Let's look at a vertical and a horizontal line. That graph application. Here's that graph in case you're still copying it down. But let's go ahead and try to graph, find the slope and the y-intercept. Okay, so this one's going to be different. And why is it going to be different? Well, for it to be a diagonal line, you've got to have both an x and a y. In this case, we only have one of the variables. And what's the variable that we have? We only have the y part. Now, what I like to do instead of memorizing different things is I like to graph it first, and then I can figure out my slope and my y-intercept if I have one from the picture itself. So when I think of y equals 5, well, that means that I've got a line that goes through y equals 5. So when we go to graph this, what is it going to look like? Well, y equals 5. Here's my y-axis. So that means we're going to go up 5. And it's going to go through that 5. How would I draw my line to go through that y equals 5? It's a y line. That means then that it is going to be a horizontal line, just like this. It goes through the y, so you can find it. And it looks like that. Now, if it is a horizontal line, then what is my slope? Does anyone remember? It's horizontal, so my slope is going to be what? Undefined or 0? Which one? Nope, watch it again. Think about it again. Horizontal line has a slope of what? 0. Vertical line has a slope that is what? Undefined. So go back and look it up if you need to, or just remember that a horizontal line has a slope of 0. Now, where does it cross the y-axis? It crosses the y-axis right here. As an ordered pair, you need to make sure it's written as an ordered pair. This is your y-intercept. As an ordered pair, that would be 0, 5. So it's a horizontal line. So y lines are horizontal. I don't like to just make you memorize that. I think it's easier if you just draw it. Figure out if you just got one variable, it's a y, and here's your y-axis here. So it goes through there like that. Slope is 0 because it's a horizontal line, and it has a y-intercept. Let's now look at a vertical line. So again, we're going to find the slope, y-intercept, if there is one, and graph it. Okay, so again, when I look at this, I see there's only one variable. If it's got one variable, then it's either a horizontal line or a vertical line. It's not going to be diagonal. If you have an x and a y both, it's diagonal. So this one only has the x part. And so the way I work this one out is graphically. That way I can see what I'm doing. And we're looking at x equals -2. So this is your x-axis here. And this is your negative x. So -2 would be over here. It has to go through that -2 on the x-axis, and the only way that it can do it is with a vertical line, like that. And so if it's a vertical line like that, That means my slope is not 0. My slope is undefined, right? Because undefined is reserved for vertical lines. Now, what about the y-intercept? I don't think there is one. Why is there no y-intercept? Well, when I look at this, does this blue line right here ever cross the y-axis here? Does it ever cross it anywhere? No, it never crosses, right? It only goes up and down. So it never crosses this y-axis here, so that's why there's no y-intercept. There's an x-intercept because it crosses the x-axis here. We normally don't want the x-intercept, we want the y-intercept. So it never crosses the y-intercept, or sorry, the y-axis. So it has no or none for the y-intercept. The last part before we take a short break is parallel and perpendicular lines. Parallel lines are going to have the exact same slope. So these lines are parallel. Y equals 8x minus 2. And y equals 8x plus 12. Same slope, right? These are the same. Another example, y equals minus 3x and y equals minus 3x plus 12. Again, parallel lines. Why? Because they have the same slope. So if your lines have the same slope, your equations, that means they are parallel. Parallel means the same. The other option is perpendicular. And perpendicular lines, they have the opposite or negative reciprocal slope. So here are some examples of perpendicular lines. How about y equals minus 4/3 x and y equals 3/4 x minus 12. This one on the left has a slope of negative 4/3. This one has a slope of 3/4. Why would they be perpendicular? Because they're negative or opposite in signs. So they are opposite in signs, and they're also flipped over. So this one has a 4/3. We flip it over, what do we get? 3/4. One is positive, one is negative. Here's another example. Another example would be, how about y equals 8x plus 10 and y equals a negative 1/8x minus 4. They would be perpendicular. Again, why? Well, this one has a slope of 8, and this one has a slope of minus 1/8. So, what do we look at? We look at the slopes first and make sure they're opposite in sign. So one is positive, one is negative, and they are. So one's positive, one's negative. Now, what happens if I take 8 and I flip it over. Okay, so that's 8 over 1. If I flip it over, then I get the 1/8, right? Flip it over, you get the other one. Now we're going to be looking at some lines, some line equations, and you're going to be telling me if these lines are parallel, perpendicular, or neither. We'll do 2 examples, and then we'll take a short break. So we're going to see if these lines are parallel, perpendicular, or neither. You may have to solve them for y. So let's look at this one. Let's say 5x plus 3y equals negative 12. And how about 3x minus 5y equals 4. Let's see if these are going to be parallel, perpendicular, or neither. So what I need to first do is I need to make sure that they're all solved for y. You can't just look at it the way it is in standard form very easily. It's always better if you solve it for y. So let's go ahead and solve each of these for y and then see what we've got. So move the 5x over. So 3y now equals a minus 5x minus 12. Divide by your 3 and reduce as much as possible. So when I reduce it down, I get minus 5/3 x. And 12 over 3 makes it a 4. The sign was negative, so the negative just comes down. Okay, so what would the slope of this one be? This one's slope would be minus 5/3, wouldn't it? What about the other one? Repeat the process. Move the 3x over with subtraction. Now we've got a minus 5y equals a minus 3x plus 4. We'll divide by our negative 5. Be careful with your signs. Reduce it down. So that gives you then y equals. Negative and negative makes it a positive 3/5 x. Positive over negative makes it a negative 4/5. And my slope is 3/5. So what do we know about these? Parallel, perpendicular, or neither? Which one would they be? These would be perpendicular. Why? Is one positive, one of them negative? Yes. If I flip one fraction over, do I get the other fraction? Yes. Right? So if I flip this one over, then I get that 3/5. So these then would be perpendicular. Let's do one more. So we're going to do one more here. How about we look at 9x plus 7y equals 12. And 14x plus 18y equals 2. Okay, so I picked this one on purpose because this is an easy one, and students generally don't have a problem until the very end, and they just pick the wrong type. Because sometimes it's easy to get mixed up what's neither and what's perpendicular. everybody knows what parallel is because if they're exactly the same, they're parallel. That's easy. But for perpendicular, they have to be opposites in signs and also flipped over. So it has to be both. So let's go ahead and solve these out. I'm going to move that 9x over. And that gives you 7y equals a negative 9x plus 12. We'll divide by our 7. And y now equals a negative 9/7 x plus 12/7. And so my slope is negative 9/7. Let's move it over and divide. Now the other one we've got to be very careful on. We're going to solve it the same way. And when we get our answer, we need to really think about how we compare these slopes. So move that 14x over. And 18y then equals a minus 14x plus 2. Divide by your 18. And you've got to reduce these down. So make sure you reduce them down. 14 and 18 both have a 2 in common. So that's going to reduce down to be a 7/9, and it's negative x there. 18 and 2 have a 2 in common. So that's going to reduce down to be a 1/9 there. Because that's going to reduce down to be 1/9. Now, here's where students make a mistake. My slope is a negative 7/9. Are these parallel, perpendicular, or neither? When we look at them, now, for it to be parallel, they have to be the same. We can tell these are definitely not the same. That's easy. What about perpendicular? For them to be perpendicular, they have to be opposites in signs. These are the same signs, right? That means it's not perpendicular. These are going to be neither. So the signs are the same. So it is neither. So it's neither parallel nor perpendicular. So it's neither parallel nor perpendicular. Why is that? Because the signs are the same. Now, if this one would have been a positive 7/9, then they would be perpendicular because they're flipped over, right? And would then be opposite signs as well. That's where students make a mistake, is one like this. They look at all the way out to the end, they get these, they compare them, and they don't take their time to think about the definition. The definition of perpendicular is opposite in signs and reciprocals are flipped over. These are not opposite in signs, so they are not perpendicular. And not parallel because they're different. We'll go ahead now and take a short break, and we will meet back here at, let's say, 10:50. So meet back here at about 10:50.